as I don't want to talk about the properties and uses of the hydrocarbons yet. I'm going to do that tomorrow. Instead, I want to get, hold on, windows out of the way. I want to get the naming and drawing aspects out of the way so that we all understand how to name and draw all of our hydrocarbons. And then tomorrow I'll talk about the properties and the uses of the alkanes, alkenes, and alkynes. So last week, I taught you how to both draw alkanes and also how to name them. So today I'm going to go through the rest of the categories for the hydrocarbons. This is going to include cycloalkanes, alkenes, cycloalkenes, and alkynes. So those are the groups I'll talk about. Now, for cycloalkanes, cycloalkanes are basically just alkanes that are in a ring. So the only thing that you have to do for the name, is to add the prefix cyclo in front of it. For example, we can change propane to cyclopropane just by putting it in a ring. Okay, so it's the same exact thing. The only difference for the formula is that, remember I told you that for alkanes, the formula is CnH2n plus 2. For cycloalkanes, it's CnH2n, because you see for the CH3 on the ends, you lose one hydrogen each to make room to join those two carbons together. Oh, there's ice. Oh, come on. Oh, okay. All right, everyone's here. Okay, so the cycloalkanes are going to have the same general formula that the alkenes do. And that's CnH2n plus 2. And again, the only difference is that you just put the prefix cyclo in front of it. This also goes for alkyl groups as well. If you have, for example, I'll just draw that, and then here, if I draw something like that, again, you have to identify the longest carbon chain. So that's 1, 2, 3, 4, 5. 5 is pent. All single bonds, so it's pentane. And then this is my only alkyl group, and it is in a ring, and there are 3 carbons. I've got 1, 2, 3 carbons. So it's cyclopropyl. So again, you just add the prefix cyclo to anything that occurs in a ring. And of course, you have to put the position number on it. So that's 3. 3 cyclopropyl pentane. Yeah. All right. When you have a cycloalkane and you have only one alkyl group, you do not need position number, because again, if I draw, let's say I draw cyclobutane, again, ane for all double bonds, bute is 4, and cyclo means it's in a ring. And if I have a methyl group, it's just methyl cyclobutane, because when you number it, if you were going to name this structure and you number it, you always, of course, give your alkyl groups the lowest number. So that would naturally be on number 1. So if you have only one, you don't need position number. Of course, if you have more than one alkyl group, same as we talked about last week, you always give your alkyl groups the lowest possible numbers. So you're always going to have at least one alkyl group in position number 1. So this is an example of cyclohexane, because you've got 1, 2, 3, 4, 5, 6 carbons. You will always start numbering and give your alkyl groups the lowest numbers. So you would go clockwise in this example and not counterclockwise. If you go counterclockwise, you're going to end up with 1 and 5 instead of 1, 3, which is lower. All right, here's two more examples of cycloalkanes. Again, we've got hexane is our parent. That's this one. And it's in a ring, so we call it cyclohexane. And again, with one alkyl group, you don't need a position number in front of methyl. And we use methyl as our branch name because there's only one carbon. And then here, cyclobutane. And we have two methyl groups on the same carbon. Because it is a dimethyl, we do have to use position numbers to make sure that we're telling, remember their instructions on how to draw it. And we have to make sure that we instruct that both of the two methyl groups are on the same carbon. If you didn't have that and you just wrote dimethyl cyclobutane, I don't know if that means that both of them are on the first carbon, or if you've got one on the first carbon and one on the third carbon, or what position numbers they are. So because they're both on the same one, that's why you need position number there. Okay, now I'm going to skip properties and uses. I'll come back to that tomorrow. We'll talk about gasoline and things like that. Okay. Now, alkenes. Alkenes contain at least one double bond. Oof, can't write. Double bond. And naming the alkenes is going to have the same rules with one exception. Sorry, there'll be two exceptions. The first exception is that the chain that you're going to count must include the double bond. So you might have a way to make the carbon chain longer, but if it means that you bypass the double bond, then that's not the parent chain. It has to include the double bond. If there is only one double bond, of course, instead of the suffix "ane," which we've been using, the suffix is "ene," added to your meth, eth, prop, but, pent, etc. prefixes. So this is a great example in the top right corner where you could create a parent carbon with 6 carbons on the blue example on the right-hand side. But doing so, you're going to exclude the double bond. So you cannot count in that direction. You must count all the way across and have only 5 carbons in the chain because you have to include the double bond. So that's the first exception. The second exception for the rules that we did before is that priority for position number is given to the double bond. So that makes actually naming alkenes and then alkynes, which I'll talk about in a minute, a lot easier because you don't have to mess around so much with numbering from left to right or right to left, because the only thing that you have to worry about given priority for the lowest position number is that double bond. And then alkyl groups come second. Okay, so I just talked about that. There's a couple of ways you can do this next rule. The number indicating the position of the double bond is placed before the name of the hydrocarbon chain and separated by a hyphen. There's a couple ways you can do this. So for example, for this one, this is the same example that I had in the previous slide. So we cannot go like this and count 1, 2, 3, 4, 5, 6, because then we're excluding the double bond. So we have to count all the way going through. And of course, that's pent. Because there's a double bond, it ends with "ene." And then the first thing that you do after identifying the parent chain is you have to number the chain so that the double bond has the lowest number. So obviously, for this example, you're going to start counting from this position number and not the other end. The other thing I want to point out is that the first carbon that contains the double bond is the number of the double bond. So what I mean by that is, let's say this is a single bond. Let's say the double bond is here. Okay. So you could either count, let's do it in purple. You could either count 1, 2, 3, 4, 5. Oh, shoot. This is like the same thing as already up there. Counting from the back. 1, 2, 3, 4, 5. Okay. So on the top, counting from left to right, you would count this as number 3 because number 3 is where the double bond starts. So this would be counting from left to right, it would be 3. Counting from right to left, however, it would be 2 because it starts on number 2 here. So in this case, you would number from right to left because you count the position of the double bond from the first carbon that participates in the bond. I was going to say something else. Oh, the other way to write it. Right. So sometimes there's going to be so much going on. The other way, which this is the way that I prefer to write position numbers for double bond, is I put it right in the middle so that it's absolutely clear that the position number belongs to the double bond, because what we use to identify the fact that there's a double bond present is the suffix "ene." So in this case, I would write it as pent 1-ene. This is just how I prefer to write it. Like I said, there's different ways. I like it this way because it kind of, it takes any kind of chance of confusion out of the equation. So for myself, this is just for myself, having a position number in the front of the name can get messy if you've got a whole bunch of alkyl groups in the front. From my mentality is if you have the 1 right before the double bond suffix, then that tells you exactly where the double bond is. This is just the way that I prefer to do it. If you like it better this way, by all means, do it that way. Totally up to you. But I'm going to give you a packet. I'll upload a packet to Google Classroom that has lots of practice naming and writing formulas for all of the different types of compounds that we're going to go through. So I'll upload that, but I will refer you to do some assignments only from particular pages of that, because like I said, it covers everything, including all of the functional groups that we're going to talk about later. So just keep referring back to that particular thing, and I will assign certain numbers of questions on certain numbers of pages, if that makes sense. So you don't have to worry about doing the whole thing. Okay, and then same thing that you do before. You put the position number of the alkyl group in front of the name of the alkyl group. So in this example, you have 1 pentene is your parent. And then because the position number is already given to the double bond, you see that this is an ethyl group and it's on number 2. So it's 2-ethyl-1-pentene. Another reason why I like putting the 1 in the middle is that it gets rid of all of this hyphen in front of the name, even though it occurs in the middle. Like I said, it's totally up to you, the way that you want to do it. Okay. What happens if there's more than 1 double bond? Same thing we do with alkyl groups. You have to indicate that there's more than 1 double bond. So this one, for example, pretty straightforward because it's just a chain of 5. 5 is pent. And then I'm going to leave a position number open for my double bonds. Oh, but wait, there's 2 double bonds. So I have to indicate that. Okay, so I've got pent. And then 2 double bonds. The prefix that we use to indicate 2 is di. And because if I write pentadiene, that's kind of difficult to say. So we add an A, pentadiene. Again, di meaning that there's 2 double bonds. So if you do it having the position number in front of the parent name, you number it 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5, counting from left to right. My numbers would be 1 and 4. Counting from right to left, my numbers are 1 and 4. So guess what? It's 1,4-pentadiene or penta-1,4-diene, if you want to write it that way. And again, for myself, putting the position numbers right before the double bonds, it just kind of takes it out of maybe getting confused with the alkyl groups. for myself if you prefer this way, or if you want to start with one, move to the other. It's really up to you, whatever you're comfortable with, whenever you're comfortable with it. Both are acceptable. If there are 3 double bonds, of course, then you use a triene. But don't forget the A in the front. And if you do position numbers in the middle of the name, the A goes with the parent prefix, and then the ending is just diene or triene. Okay, if numbering from both ends, I should say from either end, gives equal positions for the double bonds, then you go to the second priority, which is the alkyl group. So in this case, if I label from left to right, 1, 2, 3, 4, 1, 2, 3, 4. Left to right, my double bonds are 1, 3. Right to left, my double bonds are 1, 3. So if it doesn't matter regarding the double bonds, which direction I go, then I will go to the second most important thing, which is the alkyl group. And numbering from left to right, in this case, gives the methyl group a 2 instead of a 3. So I'm going to label from left to right. So again, starting with the parent name, it has 4 carbons, which is bute. There are 2 double bonds, so it's buta, and then what did I say, it was 1, 3, diene, and then this is methyl, and methyl's on 2. 2 methyl buta 1, 3 diene. If you do it the other way, it would be 2 methyl and then dash 1, 3 buta diene. So it just depends on your preference. Okay, so going through an example, first things first, identify the longest chain that contains the double bond. Because the double bond is here, starting on this carbon, I'm going to only start from that carbon, go through the double bond and see how long I can make the chain. So I either go this way, which is 4, or I go that way, but I cannot go this way that I have labeled right now, because then what do you call that? There's like an alkyl group on an alkyl group. So that absolutely cannot be the case. Or I can go up here. So my choice is between going straight back, where I've got methyl and ethyl on the 2 middle ones. Or if I go up, I've got methyl and ethyl on the 2 middle ones. So again, it doesn't matter. To make my life easy, I'm just going to go straight across. So it's bute. There's only 1 double bond. And of course, it's on number 1, bute 1-ene, because I've count from here, 1, 2, 3, and I don't care about the last one because there's nothing there. So I've got a methyl and an ethyl. Don't forget to put them in alphabetical order. So methyl comes last. Got a dash. Ethyl comes first. And then I put in my position numbers. So the ethyl is on number 2. The methyl is on number 3. So 2 ethyl, 3 methyl bute 1-ene. Or if you write it the other way, 2, I'm going to keep it the same, 2 ethyl, 3 methyl, 1 butene. That would be the only difference. But if you do it this way, then you have to have methyl dash 1 dash butene. Maybe that's why I don't like putting it in the front. I don't know. I used to write it this way, and then I found this packet that I'm going to send you, and I just, that the new method of putting it in the middle just kind of like, it rang true for me, I guess. This one, you just count 1, 2, 3, 4, 5, 6. 6 is hex. Obviously, we're going to start counting from the right-hand side to give our double bond the lowest number. So it's hex 2-ene. Or 2-hexene. Okay, what if I ask you to draw the condensed I'm going to call it the skeletal line now because I know what the name is. The skeletal structure for 4-methyl-1,3-pentadiene. All right. Drawing structural formulas from the name, like I said before, start at the end and work your way back. So pent tells you there's 5. So start with the skeletal structure for 5 first. 1, 2, 3, 4, 5. Now you've got a diene, which means there are 2 double bonds. You look to the position numbers here to figure out which ones they're on. It's on number 1, number 3. Now for number 1, I'm going to put it here. So that's 1, 2, and 3. Put it here. And then my last instruction is 4-methyl. I have started, and here's where you might make a mistake. So make sure the direction that you start counting from is the same direction you use when you place your alkyl groups. I started from left to right. I counted 1, 2, 3, and then 4. My methyl group goes on 4, boom, 1 straight up. Okay, that's the condensed structural formula. Again, I can't be bothered to spend all the time writing all that, so I prefer the skeletal way. Okay, let me go to property and uses. All right. Actually, before I go to alkynes, I want to do aromatic hydrocarbons because they are cyclic alkenes. Okay. The aromatic hydrocarbons. Basically, this is benzene. Benzene is the primary aromatic hydrocarbon. Why it's called aromatic, I'm assuming because they have a smell, because that's what aromatic means. I'm not really sure, but here's what it looks like. There's 6 chain carbon rings. They have delocalized electrons, which is super important for the structure. Because they're delocalized, there are 2 possible structures. This is actually a resonance structure, if you remember that from grade 10, where there's no one structural formula to represent the possible structures of the actual molecule. So it lies somewhere in between the 2. So for benzene, it is a 6 carbon ring with 3 double bonds. Now those double bonds are on alternate carbons. You can either have them here, here, and here, or you put them on the other 3, which would be here, here, and here. Now that structure, what I just drew, is a pain in the ass to draw over and over again, especially if you're dealing with a whole lot of questions that involve drawing benzene. So instead of drawing it that way, we've decided to make it a lot easier. And this is that meme that I sent about how you can draw the perfect hexagon, although obviously it doesn't work that well because I've been teaching this for 18 years and I still can't draw the perfect hexagon. Anyway, we use this. This is the standard structural formula for benzene. And so the circle in the middle represents these 2 possible structural formulas together. Now, benzene as a parent is treated the same way as every other parent. But if you see something like this, and then you've got maybe alkyl groups sticking out from it, might as well make it look cute. Yay. If you see something like that, then your parent name is automatically benzene. I should probably get rid of the smiley face because that's just going to confuse people. Okay. Benzene, and then you're going to identify your alkyl groups. In this example, we have 2 methyls and 2 ethyls. So we don't need position numbers for the double bonds of the benzene because benzene is benzene. So everyone knows how to draw that. So we've got dimethyl comes first. I'm going to leave some space for position numbers, and diethyl. So here's the tricky part where you have to number the carbons. If you start here, 1, 2, 3, 4, 5. So if I start there, my dimethyls are, I'm going to write it up at the top. I've got 1, 5, and my diethyls are 2, 4. Okay, so I've got a 2, 4, and 1, 5. I'm gonna change color, I guess. If I start from anywhere else, really, let's start from here. 1, 2, 3, 4, 5. If this is the case, then my ethyls are 1, 5, and my methyls are 2, 4. And I think you're gonna have to let me go back and double check on this, but I think if this is the case, that these are the lowest numbers. So my other option is 1, 5, and 2, 4. If the numbers are the same, I do believe you give the lower numbers to the first alkyl group. So it will be 1, 5 diethyl, 2, 4 dimethyl. Please let me double check that, but I'm pretty sure that's how it works, is that the low number goes to the first one. I'll double check that. Okay, so here is the structure showing you the resonance between the double bonds in benzene and how we just solidify that into one, what do you call it? One structural formula. So these are resonance hybrid bonds, and because the electrons are delocalized, that is why we use the circle, because it represents the delocalized electrons that are allowed to spread over the ring. Okay, I don't know why I had that there. All right, so any of the aromatic hydrocarbons are derivatives of benzene. So the simplest is one benzene ring. Again, if there's one alkyl group, you don't need a position number because the methyl will automatically be on number 1. And same thing as we do with everything else, you identify benzene as the parent, and then you put the alkyl groups in the front. If there's only one alkyl group, there are no numbers for positions of alkyl groups. And of course, if there's more than one, the numbers give the alkyl groups the lowest number. So if I want you to draw the condensed structural formula for 1,2-dimethylbenzene, you always start with the parent, which is benzene. So you say, okay, hexagon time, whoop. And then 1, 2, it really doesn't matter where on the hexagon you start numbering 1 and 2, as long as you put them next to each other. So I usually start at the top. So I go 1, 2. If you're left-handed, maybe you go 1, 2. If you're just weird, maybe you go 1, 2. Totally up to you. As long as they are next to each other, so that if you count, you start with one of them and you count 1, 2. Okay, and then I have the whole explanation, blah, 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 blah. All right, so if we're going to name this, again, first thing that you're going to do is say, aha, benzene. And then what's that? Ethyl. Ethylbenzene. One alkyl group, no need for position numbers. If you want to draw 1-ethyl-4-methylbenzene, again, start with your benzene. And again, I just usually start at the top. So there's my ethyl. And I go no, it's not a counter, I go clockwise. I don't know if that's like a normal thing or what. So I count 1, 2, 3, and that's 4. Boop. There, 1-ethyl-4-methylbenzene. Right, so if you take mine and you rotate it to the left, what is that, 45 degrees? Same thing. All right, properties and uses are coming tomorrow. Now I'm going to go back to reality. No. Right, the last group are the alkynes. Tryptophan bond. Okay, a triple covalent bond. You're going to do exactly the same thing that you've done with the alkenes, only your parent carbon chain is going to end with the suffix -ine. The simplest alkyne, and as well as the simplest alkene, they have 2 carbon atoms. So if I ask you, what's the simplest alkane? Oops, that's methane. But there is no such thing as methane or methine because you can't have a double bond if you've only got 1 carbon. So the simplest alkene is ethene, C2H2N, right? So in this case, it would be C2H4. And the simplest alkyne is ethyne. And the formula for there is C2H2N minus 2. So in this case, C2H2. So again, if you see the formula and I ask you, is that an alkane, alkene, or alkyne, you use these general formulas. The only difference is you can't, from the general formula, tell the difference between an alkene and a cycloalkane, because both of them have the formula C2H2N plus, or sorry, H2N. Oh, that's it, C2H2N. Okay, so that already. Right, now one of the things that I mentioned in the very beginning, for the general formula, you got C2H2N plus 2, C2H2N, C2H2N minus 2. So as you move down the series, they are different by 2 hydrogens and 2 hydrogens here. Again, it's a homologous series. And then if you go for the alkanes, you start with methane, and then you go to C2H6, ethane, propane, butane. The difference between each of these is 1 C and 2 H's, 1 unit, same unit over and over again. Again, called homologous series. Right, so alkane, alkene, alkyne, same thing. So it's different by 2 hydrogens. And that's because you're adding another bond. So you go from single to double, you have to get rid of 2 hydrogens. Double to triple, 2 hydrogens. Okay, so 1, 2, 3, 4, 5. 5 is pent. Triple bond means yne. And of course, you start counting from right to left to give your triple bond the lowest number, 1 pentyne or pent, 1 yne. And this one, straight across, because you have to include the triple bond. 4 is bute. We're going to start numbering from the left to give our triple bond the lowest number. So it's 1 butyne. And this is a methyl group on number 3, 3-methyl-1-butyne. Okay. Give me a second.